Alright, so we're going to look at combinations of functions here. A lot of this we're going to run through quickly. We're going to slow down once we get to composition. Alright, but just as a matter of review, make sure you understand the notation. Alright, guys, sometimes the notation here is what throws people off, okay? So when you see f plus g of x, that's the same thing as taking the function f of x plus the function g of x. Alright, so if I'm doing that with these two functions, I'm simply taking x plus 1 and I'm adding to it x squared plus 2x plus 1. So I get x squared plus 3x plus 2. Okay? Really simple. If I were asked to evaluate it, like it said, f plus g of 7, okay? Here's the thing. You have a choice at this point to either plug 7 into each function separately or to plug 7 into this result here, okay? So if I do f of 7, that's 8. If I do g of 7, that's 49 plus 14, which is 63 plus 1 is 64. And I would do 8 plus 64 and get 72. Alright? Or I could plug 7 into this result. 49 plus 21 is 70 plus 2 is 72. Alright? So if you're asked to evaluate like this, you have the choice. The reason why we do this in terms of x is because if we need to evaluate a number of values like 7, 8, 9, 20, 15, if we wanted to do it a bunch of times, it's going to be faster to just be evaluating this result, okay, this result here, than it is to evaluate each of these separately and then add them together every time, okay? So that's kind of our purpose here.
Where'd you get x plus 1 plus x squared plus 2x plus 1?
This is our f of x. That's the x plus 1.
Okay. I
Okay.
didn't see that.
And then here's our g of x. So that's g of x. So f of x plus g of x. Okay. Subtraction. F minus g of x. The only thing you have to be careful about here is what?
Your symbol.
What? Parentheses, how so?
Okay, so if it's minus, you will change all the symbol in the parentheses.
Okay, very good. You got f of x is x plus 1. I've got to subtract all of g of x. Not just the x squared. So you got to make sure you distribute that negative. Okay? So, that's going to be a negative x squared. X minus 2x is negative x. 1 minus 1 is 0. So my result is simply negative x squared minus x. Okay? Be careful using your order of operations. Be careful with your negatives and such. Alright? Those are the little things in this section that are going to throw you off. And frankly are just really annoying mistakes to make. Okay? Because you know it. Alright? It's just a matter of being careful. Okay, so there's our addition and subtraction. Yeah.
It's not out of like space, but are we gonna have another quiz in this chapter?
In this chapter?
Like in unit 3.
Oh, in the trimester? No.
Yeah, but it's like.
So we've gone.
So. Alright, so moving on, we have also multiplication. Okay? Multiplication. If I'm doing f times g of x, it's x plus 1 times x squared plus 2x plus 1. And how do we multiply these?
Foil.
Alright, FOIL, and applying that idea there. Okay, so we've got to distribute the x to all three parts here. And then I've got to distribute the 1 to all three parts. Okay? By the way, a little trick to this, not a trick, but just a way to help you stay organized. if you have this in decreasing degree, x and then the 1, and then you have the x squared, then the x, then the 1. When you do this, if when you distribute the 1, you kind of come down on the next line and move it over one space, notice what happens with our like terms. They all line up in nice little columns. Okay? So that's kind of a nice way of doing it. Now we have x cubed plus 3x squared plus 3x plus 1. Okay? Yeah, everyone all right with that? Okay, let's move on. Now we have division. Okay? F of x divided by g of x. All right, so here our function is x plus 1 over x squared plus 2x plus 1. All right, now here's something that we're going to deal with a lot more later on when we are working with rational functions in this unit. Okay, but one thing that we can do with this is we have to be careful about a domain. All right, so we are going to factor. The denominator factors into what?
X plus 1, x plus 1.
Very good. X plus 1 times x plus 1, or x plus 1 squared. Very good. So what is my domain?
Well, now it's just, if you cross them out, the numerator from the denominator is going to be 1 over x plus 1.
Okay, well, that's what our function simplifies down to. You're right. But you always identify the domain before you reduce anything. Okay? So our domain here would be what?
It can be negative 1.
Very good. X cannot be negative 1. It can be any other real number, not negative 1, because then I'd be dividing by 0. Okay? Now, for a graph of this, okay, notice these are the asymptotes as they would be. Okay? This is where it would be if it were the parent function. However, let me zoom in a little bit. However, this is the function, the parent function, translated how?
Horizontally 1 unit to the left.
Very good. 1 unit to the left. So my vertical asymptote stays the same, but my horizontal is actually going to be over here at negative 1. Okay? And then from there, I go up 1 over 1, I go down 1 over 1. I've got these two parts of my hyperbola. Okay? Like this. Okay? So, that's what that would look like if we were to graph it. Okay? So just trying to tie this together with what we did in our previous section. Okay? Questions? Comments? Relevant to what we're talking about? Yes?
Oh, no, not relevant to what we're talking.
Okay. We could talk later then. Alright, so let's talk about function composition. Alright? Function composition. What we're creating in a function composition is really just a multi-step process. Okay? We want to do one thing with x, and then we want to do another thing with x. Okay? This is kind of like, a factory that's trying to produce a car. They might have different departments. One is assembling the frame. One might be assembling the engine. One might be assembling something else. Okay? And then you take each of their work and you put it together to form a car. Okay? So we're doing multiple steps and then putting those steps together. Okay? For example, you have a frame. The people who build the engine are taking parts, they build an engine, and then they put it into the frame. Okay? So you're doing something first, then you're plugging that result into another function. okay? Notice the notation here. It looks a little like multiplication, but notice that this is an open circle there, okay? That's a operator that indicates that we're doing composition. So that we would read that f composed of g of x, or written like this, you could read it as f of g of x. Okay? Now all of this is review, but it is good to just go through it again. So I take f is x plus 1. Alright? But instead of x plus 1, this is telling me to take f of the g of x. So it's now g of x
So you plug
plus 1. I'm plugging in g of x to what f is.
I remember this and I love this. I love
Good.
it. It's fun.
Alright, so now what's g of x? It's x squared plus 2x plus 1 plus 1. Alright, is now x squared plus 2x plus 2. Donald?
Means this has a gx become x. Yeah.
The g of x takes the place of the
fx.
x.
Yeah.
Yes. Okay? Down here we have another one,
Opposite.
kind of the opposite way. Now instead of x squared plus 2x plus 1, we're going to do f of x squared plus 2 times f of x plus 1. Okay? We're replacing the x and g of x with a new function f of x. Okay? So f of x is x plus 1, so it's x plus 1 squared plus 2 times x plus 1 plus 1. And you guys know how to FOIL and distribute, so this whole thing is going to end up giving us x squared plus 4x plus 4. Once you simplify the whole thing.
Wait, why is it 4x? You wanna be
Because you FOIL and you get 2x, but then you have the other 2 that you distributed to the x plus 1.
Oh.
I know you guys can work it out, I just
Yeah.
skipped to the final answer. Alright, so there's a quick overview of the operations. When we're evaluating, last thing here, f of g of 3, okay? You have options again. Okay? You have options. You can evaluate what g of 3 is. Alright? G of 3
16.
is 3 squared plus 2 times 3 plus 1. So yeah, 9 plus 6 plus 1 is going to be 16. So that we could rewrite now as f of 16, which is 16 plus 1 equal to 17. The other option, since I know what f of g of x is I could simply plug it into that right off the bat. Okay? I could instead of plugging 3 into g and then plugging 16 into f, I could simply plug 3 in to what we got up here. Okay? So 3 squared plus 2 times 3 plus 2. And I would again get 17. Either way works. Okay? So, alright guys, have a great day.